Imagine the entire 13.8 billion year history of the universe compressed into one calendar year. Midnight on January 1st is the Big Bang. Space itself begins expanding. In the first moments, inflation stretches the universe. Particles appear, and matter survives in a slight excess over antimatter. On this scale, 1 day equals almost 38 million years, and 1 second equals about 438 years. The young universe is a brilliant plasma, too hot for atoms. About 380,000 real years later, only 14 minutes after cosmic midnight, electrons join nuclei and light travels freely. That ancient glow becomes the cosmic microwave background. Then darkness returns. There are no stars yet, only hydrogen, helium, dark matter, and tiny density differences that gravity slowly strengthens. Around January 6th, the first stars ignite. They are massive, hot, and short-lived. Their explosions seed space with heavier elements. By roughly January 11th, early galaxies are assembling, while black holes begin growing in some galactic centers. The exact timing is still being refined, but modern telescopes are now seeing surprisingly bright galaxies from this very young universe. Through the cosmic winter, spring, and summer, galaxies merge and stars repeatedly form and die. Inside stars, fusion produces carbon, oxygen, silicon, and iron. Supernovas scatter those elements into space. New stars inherit the enriched material. Every rocky planet, ocean, bone, and breath depends on this long chain of stellar recycling. On September 1st, a cloud inside the Milky Way collapses. The sun forms at the center of a spinning disk. Dust sticks into pebbles, planetesimals, and planets. Earth forms around September 2nd. A giant collision probably produces the moon around September 3rd. The solar system is violent, crowded, and still changing its orbits. Earth cools, oceans become stable, and the first clear evidence of life appears around late September. The exact origin is uncertain. For most of October and November, life is microscopic. Photosynthetic microbes release oxygen. Complex cells appear. The planet slowly changes from a world ruled by chemistry and simple cells into one capable of supporting larger organisms. Around December 10th, multicellular life becomes common. By December 17th, the Cambrian explosion fills the oceans with diverse animals. Plants spread across land around December 19th. Vertebrates follow by December 22nd. Forests, insects, reefs, and predators transform the biosphere. Almost everything familiar arrives only during the final 2 weeks of the cosmic year. Late on December 25th, dinosaurs appear. Early mammals live beside them, and birds evolve from feathered dinosaurs. Flowering plants spread around December 28th. On December 30th, an asteroid strikes Earth and helps end all non-avian dinosaurs. Mammals rapidly diversify, primates appear, and the stage is set for the human branch. On December 31st, our lineage separates from other apes during the evening. Homo sapiens appears around 11:48 at night, only about 12 minutes before midnight. Small groups survive through cooperation, language, tools, and memory. The universe has existed for almost the entire year before any human looks up and wonders where it came from. During those final minutes, humans spread across continents, cross coastlines and ice-age landscapes, paint caves, bury their dead, shape stone and bone, and build stories about the sky. Different populations adapt to deserts, forests, mountains, and cold steppe. This is not one straight march of progress, but a branching human history filled with invention, loss, contact, and migration. Agriculture begins around 11:59 and 33 seconds. People domesticate plants and animals in several regions, create permanent settlements, and produce food surpluses. Villages grow, labor becomes specialized, and societies become more unequal and organized. In cosmic time, the entire agricultural revolution occupies less than the final half minute of the year. Writing appears about 12 seconds before midnight. Cities, kingdoms, pyramids, trade routes, legal codes, classical empires, world religions, navigation, paper, gunpowder, and printing all flash by in the final seconds. Civilizations rise and fall almost instantly on the cosmic clock, yet each leaves ideas, languages, technologies, and consequences for the people who follow. The scientific revolution, industrial machines, electricity, photography, radio, aviation, antibiotics, nuclear weapons, computers, rockets, the moon landing, satellites, and the internet all fit inside the final second. Humanity learns to read ancient light, split atoms, alter the climate, and send machines beyond the solar system. Our power grows far faster than our experience using it. Midnight is now. Every person who ever lived appears near the final edge of the calendar. The cosmic year makes human history look brief, but not meaningless. It shows that complexity took immense time to build, while destruction can happen quickly. The next second has not been written. For the first time, part of the universe can understand its own history and choose what happens next.